Hey, MathCook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathcook.com. Let's MathCook it up. This question says graph f of x equals 3 to the x plus 2 minus 4 using transformations. State the domain, range, and horizontal asymptote. So this function is an exponential graph, and the base function, or the parent function, is y equals 3 to the x. So it's an exponential function. Here's some information about how to graph a parent graph. So if you have y equals b to the x, then these are the points on the parent graph. So we have negative 1, 1 over b, 0, 1, and 1b. All three of those points are here. And notice this graph is an exponential graph. As the graph goes to the left, it approaches the horizontal asymptote y equals 0 forever. It literally goes forever here and never touches this asymptote. And then as you go to the right forever, it goes up and to the right forever. So here is an exponential graph. All right, so let's take a look at our function here. And what is our parent graph when we look at it here? So our parent graph is going to be y equals 3 to the x. So I'll write that in our chart here. The parent is 3 to the x. All right, so based on that, let's go ahead and write our three main points. So we have negative 1, 1 over b, but that's 1 over 3 in this case. Then the next point is 0, 1, so that's always 0, 1. And then the next point is 1, comma b. b in this case is 3, so it'll be 1, comma 3. All right, so those are our parent points there. Now we're going to transcribe these to our child function based on the graph here by looking at the transformations. So here's our graph. So what kind of transformations are happening? Well, we have an x plus 2. So what does that do to the graph? That's going to shift it left 2. So really important. I always tell my students, x's lie. So you would think x plus 2 would shift to the right, but it actually shifts the graph to the left. Then we have a negative 4 here. So that negative 4 is going to shift the graph down 4 because it's negative. So it's going to shift it down 4. All right, so what that looks like for our child function, since we're going left 2, that's going to affect the x value. Every x value will go left 2. So that's going to give us an x minus 2. Now the shift down 4 is going to affect the y value. So instead of y, we're going to go y minus 4 because it's going down 4. All right, so now we write down our points based on our parent graph. So let's do the x's first. So we're going to take each of these x values and subtract 2. So negative 1 minus 2 is minus 3. And then we have 0 minus 2, which is minus 2. And lastly, we have 1 minus 2, which is negative 1. All right, we do the same thing with the y's. So we have 1/3 minus 4. That would give you negative 3 and 2/3. And then 1, we have a 1 here, minus 4, which is minus 3. And lastly, we have 3 minus 4, which is negative 1. All right, so here are our 3 points that we're going to graph to give us our function on the graph. I'm going to go ahead and erase our information on the parent graphs here and bring up our graph. All right, so the first thing we want to find is the horizontal asymptote when we're graphing. So the horizontal asymptote is the y shift of the exponential graph. So here we're moving down 4. That is the y shift. So that tells us our horizontal asymptote is going to be y equals negative 4. So the original horizontal asymptote for the parent graph is just here at y equals 0. But now we're moving down 4 here, so I'm going to go ahead and graph that. So this is negative 4. So we're going to graph this here. All right, so we'll go ahead and label that. That is y equals negative 4. So there is our horizontal asymptote for this graph. So that'll guide the graph. All right, let's go ahead and graph our points. So we have negative 3, negative 3 and 2/3. So we're going to start at the origin, go left 3, and then down 3 and 2/3. So that's like right there. And then next we have the point -2, -3. So we're going to go left 2, down 3. So that's like right there. And then we have -1, -1. So left 1, down 1. So that's right there. All right, so now we can kind of see the shape of this graph. It looks like it's going to go like this here. Go up and to the right forever, and then approach this asymptote as we go left forever. So let's do our best to graph it here. Goes up and to the right forever, and to the left forever here. All right, so there is our graph. We'll go ahead and label that. That is our graph of f of x equals 3 to the x plus 4, sorry, x plus 2, and then minus 4. All right, so we have our graph labeled. So now we have to find our domain and range. And domain and range is easiest to find just by looking at the graph here. So for domain, it's all the possible x values. So we go left to right. Now it's defined, see how this goes forever to the left? So it's defined at -infinity. As we move to the right, it's also defined for all these x values. And this goes to the right forever and up, but we are concerned about the right for the domain. So it goes right and up forever. So it's defined for all these x values forever to the right. So therefore, our domain is -infinity to infinity. There's no restrictions on x. The range. So is range, we move from the bottom here to the top because it's all the possible y values. So we start at the bottom. Is it defined here? No, it's not. As we move up, it starts to be defined kind of at -4, even though at -4 it's not defined because the graph approaches -4 but never touches it. But it does kind of start at -4, so we'll put a parentheses at -4 because it starts right above it here. And then it's defined for all these values forever, forever, going up forever. So our range is going to be parentheses because it does not include -4 all the way to infinity. All right, so we have graphed our function f of x here using transformations, and we have found the domain, range, and asymptotes for it. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.